CPM Math 3, Problem 1-58. We are being asked to create multiple representations to represent the relationship that's happening with this lemon tree that was planted at 2 feet tall, which happens to be the same as 24 inches. And then it grows 3 inches every week. And it makes sense to turn this into inches so that we can use the 3 in our table. So if you notice that at the time it was planted, time 0, 24 inches tall. After let's see, 1 week has gone by, it's gone up 3 inches. So we see a constant rate of change here of 3 inches per week. Okay, so if you graph it, notice the proper graph here has an X and Y axis that is labeled proper scale, and this tree is growing constantly. So we do have a continuous graph. This is not a discrete graph. Okay, so part B says if the tree continues to grow at this rate, when will it be 6 feet tall? So 6 feet is the same, if I take 6 times 12, that's the same as 72 inches. So I'm actually looking for my Y value to be 72 inches, and that will tell us what our X value is. We could find this on the table if we continue the table. We could find it in the graph if we continue the graph, but I'm actually going to use the equation, okay? So the Y value we want to be 72. So I can just substitute 72, 3x plus 24, and I can solve this equation like normal. And that will tell me the X value when all is said and done. So when I solve this equation, I get x equals 16, and that means after 16 weeks, my tree will be 6 feet tall. Kind of a crazy, fast-growing tree. Our part C here is asking us to state the possible inputs and outputs, and we know inputs is considered mathematically the domain, and the outputs are considered the range. They are simply asking for what is the domain and range of this graph. So logically, the possible inputs of this graph are all of those X values, alrighty? And notice how it has to start at time 0. We do not have a time -1, like 1 year ago or 2 weeks ago or whatever. So the domain of our graph is that X has to be greater than or equal to 0. I guess theoretically we could go on to infinity time-wise. Trees do not live forever, so I guess if it was X is greater than 1 million, or X is 1 million, there would be a problem with that. But just for the sake, we could limit it a little bit more, but we're just going to say X is greater than or equal to 0 weeks at this point. Okay, a range for this situation is all of those possible outputs, the logical height of our tree. So the tree began at 24 inches. All right, so that's the lowest value our tree is going to be. The highest value for our tree, I don't know, how many inches do we suppose? 6 feet is the 72 inches. Let's ballpark, I don't know. Let's see, 10 feet tall. 10 times 12 is 120. So let's just say 120 possible inches. All right, so less than or equal to, less than or equal to. Now this 120, you may have come up with a different number. Maybe yours is one of the tallest trees on the planet and it's a different number. That's okay. What we're doing here is just simply recognizing there is there's going to be a limit. The tree can't just grow on to infinity.